Welcome to Daily Papers, the podcast where we break down the latest academic research into bite-sized, easy-to-understand conversations.
Today, we're diving into the world of large language models, or LLMs, the AI brains behind things like ChatGPT. We often think of them as these black boxes, but researchers are constantly trying to find ways to peek inside and even steer their behavior.
Right, like what if you could tell an AI, hey, be a little more formal? Or for this next question, I need you to be as truthful as possible. It's a huge area of research called AI alignment, and it's all about making sure these powerful tools do what we want them to do.
Exactly. And a popular tool for this is something called a steering vector. This paper, titled Inverted Detection and Control in Steering Vectors, finds a really fascinating and counterintuitive quirk with this method.
Okay, let's start there. What exactly is a steering vector? Is it as simple as it sounds?
It pretty much is. Imagine the LLM has a kind of internal thought space, a giant multi-dimensional map of concepts. In one area of this map, you have the model's internal representation for truthful statements, and in another, you have the representation for untruthful statements.
So it's like a mental geography for the AI.
Precisely. A steering vector is basically just an arrow that points from the untruthful region toward the truthful region. The idea is that if you're inside the AI during its thought process and give its internal state a little nudge along that arrow, its final output should be more truthful.
That makes perfect sense. You find the direction of a concept and you push the AI in that direction. Simple. I feel like there's a but coming.
There is a huge but. The authors of this paper, Max Torop, Aria Masoomi, and Jennifer Dye, discovered that this simple, logical assumption can be completely wrong. They found certain steering vectors that are fantastic at detecting the difference between truthful and untruthful. The arrow points perfectly. But when they used that arrow to control the model,
Let me guess, it did the opposite?
exactly. Pushing the model in the direction of truthfulness consistently made it less truthful. They call these inverted steering vectors, or ISVs for short.
That's wild. It's like having a compass that correctly tells you where north is, but every time you walk in the direction it points, you end up heading south.
That's the perfect analogy. And this isn't just a one-off glitch. They found these inverted vectors across 3 different major language models and for 5 different concepts, including things like myopia, which is short-sighted thinking, and wealth-seeking. The compass was broken in the same weird way in lots of different places.
So, do we have any idea why this happens? Is the AI just being rebellious?
The researchers have a theory, and it has to do with how information flows inside the model. Think of the AI's brain like a big corporation with lots of different departments, or attention heads, as they're called. Applying a steering vector is like sending a memo to a key department.
Okay, I'm with you. A normal steering vector is a memo that says prioritize truthfulness. That department gets it and passes along the message so all the other departments also start prioritizing truthfulness. The final company report is truthful.
Right. But with an inverted steering vector, it's like you send that same prioritized truthfulness memo, but somewhere in the chain of command, the message gets flipped. The downstream departments receive a memo that effectively says prioritize untruthfulness. The paper calls this spoofing absence instead of spoofing presence. The initial nudge is right, but the effect it has on the rest of the system is inverted.
The message gets lost in translation, but in a very specific, backwards way. So if you can't trust the compass, how do you navigate? How do you figure out which vectors are normal and which ones are inverted?
Well, the slow and expensive way is to generate a ton of text for every single vector and have another powerful AI, like GPT-4, read and score the outputs. That takes forever.
Right, you'd have to wait and see if the company's stock tanks before you realize the memo was misinterpreted.
Exactly. So the real breakthrough in this paper is that the authors developed a clever method to detect these inverted vectors without any text generation at all. They figured out how to measure the internal corporate communications directly.
They're listening in on the office chatter between departments.
That's a great way to put it. Their method, called the representation response, basically checks how those downstream departments are reacting to the initial memo. If they see the other departments reacting positively to the truthfulness memo, they know it's a regular vector. If they see them reacting negatively, they've found an inverted one.
And once they find an inverted vector, what's the fix? Is it complicated?
It's brilliantly simple. They just flip it. If they know walking north on the compass takes you south, they just decide to walk south on the compass to go north. They take the inverted vector and just push the model in the opposite direction to get the effect they want.
It's so simple once you know the problem. What kind of difference did this make?
A huge one. They took an existing popular steering method called inference time intervention, or ITI, which was unknowingly using some of these inverted vectors incorrectly. By applying their fix, finding the inverted vectors, and flipping their signs, they improved the technique's performance in 27 out of 30 experiments. The gains were massive, in one case boosting the steering effectiveness by 138%.
Wow, a 138% improvement just by figuring out which of your tools are secretly working backwards.
It really shows how much we still have to learn about what's going on inside these complex models. Our human intuition about how they should work isn't always right. A direction that seems clearly to separate one concept from another might not be the direction that actually controls it.
It's a great reminder that when we build these incredibly complex systems, we also have to build equally clever tools to understand and debug them. What looks like a straight line might actually be a U-turn inside the AI's mind.
And this paper gives us a much better map to navigate those turns.
A fascinating look into the quirks of the AI brain. That's all the time we have for today on Daily Papers.
Thanks for listening.